There we go. Look at, we got 25. We got 30. It's coming.
Excellent. They're coming in. Hi,
So
everybody.
nice to see lots of people coming on stream.
Ah, it's nice. Yeah. How's everybody doing? Oh, Phil's here. Hi, Phil.
Hi, Phil.
Hi, everybody. And I'm going to mention this now because this came up on a different live stream. If you do want to chat with everybody, not just us, because we can see all the messages you send, but if you want to chat with everyone, make sure that you change that little blue bar above the chat panel from all panelists to all panelists and attendees, as Stephen Bedingfield has done, so that you can talk with everybody over in the corner. So welcome.
We got a question there already.
Oh, do we?
Are these recorded? So it's the YouTube, right?
Yes, they're the last two sessions were recorded. This session is being recorded. We stream them automatically to our YouTube channel, but we don't list them because it's just for members. And so I will send out in the chat, I will send out the link to the playlist, and then we'll add them there as we finish them, and you should be able to see the last sessions as well. And hello from Connecticut. That's a long way.
Right on.
Always nice to see our international friends on here. So I guess we'll get started. We're still waiting for one of our speakers, but he'll hopefully join us soon. He's talking about the moon. So that's at the end of our talk anyway. Oh, and I will run our poll. I have a poll quickly just to see what you guys are all interested in. So that should be popping up. We're going to be covering eclipses this time, which we had mentioned last time, but we ran out of time. We're going to talk about the moon and we're going to talk about the sun. So please fill out that poll for the sections that you would like to see the most. You can select more than one, and we will do our best to adjust accordingly with the time that we have. Alrighty, and I'm just going to get you guys the link to the playlist right now. Okay, in the chat, you will find the link, and so that will be updated routinely after the sessions are finished. Usually I get to it the day of, sometimes it's the next day, so keep an eye out there. Alrighty, we've got—
Just a little note for David Wormuth. $200 isn't the cost of putting out an electronic handbook. It's a lot of work for me, the editor, and it isn't going to happen again.
Oh man. Yeah, so, no, it's just not worth the time and the money.
Really, the money isn't it, it's the time and the effort put into it with so little uptake. That was the disappointing part, was how few people took advantage of it.
That's too bad. Yeah. I'm going to end the poll so that we have a good idea, and we have a clear winner this time. And here we go. We're going to be, lunar observing is like top of the list for a lot of folks. So we'll spend lots of time on that, and a little bit more on the moon, and a little, looks like solar observing is our tie for second place as well. So that's great because those are the two main focuses of this session. Excellent.
Let me start off by talking about eclipses.
Yes.
Which is part of lunar observing. I see that's got the top rank there. So
yeah, it does. And actually both the eclipses have lots of folks interested in them as well. So I'm going to share my screen with the electronic, there we go. There's our— oh wait, a little bit too far ahead. I was skipping ahead to the moon.
122.
122. Lots to cover today. Okay, 122. There we are.
You're close. Yep. So, this is a tremendous amount of information that we got on our plate today. So it's probably going to run at least to an hour. Nevertheless, if you can look at that image there that's shown with the descending node and the ascending node, those two nodes are where eclipses occur. So when the moon is in its orbit and it's going around the Earth, and it gets to that descending node, it's going to below the ecliptic. That's eclipse season, the little gray areas on each side of it. So you could have potentially 3 eclipses in that area. You could have a lunar eclipse at the beginning, a solar eclipse in the middle, and then a lunar eclipse again at the end. So you could have 3 eclipses there in one season. And then the next season, you could have, coming up from the ascending node, you could have 3 more eclipses in there. So that's 6 eclipses in one year. And there's a potential for having 1 more. Depends on how the year begins. You know, you could have the beginning of the year like January 2nd, could be a solar eclipse is the tail end of an eclipse season from the previous year, and then 6 more eclipses. So you could have 7 in a year, potentially. Every year has at least 4. So in that gray area of the descending node, and then 6 months later, that gray area in the ascending node, you're going to have at least 2 eclipses in each one of those seasons. So you know that every 6 months there's going to be an eclipse, and it gradually works forward in the year. Just like we talked about the node of the ecliptic, it gradually rotates clockwise if you viewed it from above. Same as the eclipse seasons, they follow the nodes and where it intersects with the ecliptic. So each year you'll see like the full moon gets a month, you know, a little bit earlier and earlier and earlier as you go through the year. Same thing with the eclipse seasons. So we've got this map. I was astounded when I saw this map because I'll be 100 years old when it reaches fruition in 2046. I don't know if I'll still be the Observer's Handbook editor by then, but I plan to keep going on it for quite a while. But you can see on here where the seasons occur. There's the one that went across the United States there in 2017. And it looks almost identical. It's just 2045, August the 12th.
Oh, yeah.
And 2034, which is almost identical shape. Oh, pardon me.
2024?
2027, because they're 18 years apart. And those are the Serous series. They're separated by 18 years and a few hours. So that's why they don't occur in the same place on the Earth, but they have the same shape. So you can see the ones 2021, December the 4th, that'll be next year on December the 4th. And the one in 2039, 18 years later, on December the 15th, over Antarctica. They're identical shape, but separated by 18 years and a few hours.
That's so cool.
And you can look through that and see all the different series of the solar eclipse paths, and you would know then that in 2024 there's going to be one that comes up across the United States and right over Montreal and Toronto. So that'll be people will be looking forward to that. I'm sure there's lots of people ready to travel to there already.
Mm-hmm. I have a quick question just out of my own curiosity. The one in 2044, so up over like BC, Alberta, and then up through the northern parts of Canada, and 2026, is that the same path, just affected differently by the map projection?
Yeah, it's a Mercator projection, so yeah, it's the same path.
Okay.
You just have to look at how many years separate them. If it's 18 years, it's the same one.
Right, that makes sense. Cool.
Yep. And then, of course, the text below it gives it a good explanation of that. And then we go on into the Serous series. And the Serous series has been known for like 4,000 years. So somebody in the Chaldean culture was monitoring what this moon was doing and what the eclipses were doing over a long period of time, because they would have had to do it over a long period to recognize that they were 18 years apart. So there was a lot of study like 4,000 years ago, and a lot of this is not new stuff. And the same as the Metonic Cycle that's mentioned there on page 125. This is by an astronomer named Meton. He figured it out 430 BCE. That's a long time ago.
Yeah, okay.
2,500 years ago. He had this all figured out, and it's a similar kind of a cycle, but it's 19-year intervals instead of 18 years.
So I guess this is one of these things that's easier to observe, generally speaking, for folks who didn't have the technology, because you didn't need a telescope. You could see it no matter what, right?
Yeah. Alice Sterling is just saying that there were OCD people then. Quite true. Just like there are today. Yeah.
Oh, that's great.
Okay, so the next session, or section, I should say, starting here with Fred Espenak's Eclipses for 2020, you can see there's 6 in the year. As I was saying earlier, there's 6 eclipses this year, and none of them are spectacular. There's the total solar eclipse on December the 14th. is people are already planning to travel to that. I know Stephen Bedingfield probably with Lynn are heading to Chile to watch it down there. It's a little bit south of Santiago, and it'll briefly cut across the South American tip. And all the rest of them are a penumbral lunar eclipse. You would have a hard time telling that there was an eclipse going on if you saw a penumbral, because it just barely enters the Earth's shadow, like that one. You know, you may see some darkening on the top of the moon, but then again, you may not.
So the more interesting lunar eclipses are the ones where it enters the umbra, right?
Yep.
Okay.
Yeah, if it enters the umbra, then the dark shadow covers the moon, and you can see a definite change in the color and intensity and that stuff. But if it's a penumbral eclipse, you'd be hard pressed to tell when it was on or not. So they're kind of insignificant eclipses.
Ooh. Oh, we got a lot of them.
I think I said all I need to say. Everything else that you need to say about eclipses is in there, and everything that Fred puts into the handbook is online on his Mr. Eclipse site.
Oh, okay.
So what we've got is a digest of his site.
Okay, it's mreclipse.com.
He's got a couple of sites, but it's ECLIPSEwise.com.
Okay. Thank you, Stephen. He already got it.
He used to have a site that was sponsored by NASA, and he's retired now, so it's his own site, ECLIPSEwise.com.
Okay, cool.
So, and he's got 5,000 years of eclipses if you're really interested. If you're like Alistair and you're an OCD, go for it.
Oh boy.
Here's Roy Bishop's map of the moon that he did in India Inc. many years ago. That's been around for a long time, and it's just as valid today as it was then. Lots of information there, and you can see all the Maria and the Lacus are all named. The lunar probes are all identified in the next page where they landed.
That's what this all.
And a whole bunch of other stuff.
Oh boy.
Yeah. And there we got the new moon dates. You can see scroll up just a little bit.
There we go.
Those are also in the calendar on the inside back cover.
Okay. And for those of you who are new to observing, those are the dates to mark and those are also the dates to plan to go up to your cottage, because those are the dates when the sky's darkest.
Yeah, you don't want to go 2 weeks earlier than those, because that's the full moon. And Pat Kelly had sort of mentioned it last week, how much information the editor has to do. This is part of it. The universal time of new moon dates, the times of moonrise and moonsets, and all the following tables are all mine. I do all of that stuff. And I get it from the Astronomical Almanac.
Wow.
Yeah, it takes a lot of work. It takes most of May, June, July, and August.
Wow. Okay. So this is the entire year of moonrise and set times, and then it's adjusted by latitude, and you can make minor adjustments in the table to your specific latitude. Is that right? Or no, that's longitude.
Absolutely correct. Yeah.
Wow. Okay.
There's an example on the page up, right at the bottom. Here's an example.
Right there? Okay.
The longitude of the David Dunlop Observatory is blah, blah, blah. And it tells you when the moonrise and moonset will be there.
Wow. Okay. Wow. All right. Yes. Alistair says for when your smartphone fails. This is really cool. It's cool to be able to do all the math yourself on this.
And then that table that we showed there with the longitudes, there's a blank copy on the supplements page that you can download and print for yourself. That one.
Oh, perfect. Okay.
All right. I think it's time to turn it over to Bruce McCurdy about lunar observing.
Yes.
Now.
Bruce, we did a little poll, and this was a very popular section. So you've got.
Yeah, I saw that.
Yeah.
Wasn't a surprise, but that's great.
Oh, no. The moon's amazing, and you're amazing, Bruce.
I I've been fascinated by the moon since the 1960s, when, of course, the space race was underway, and both USA and USSR were um, trying to be the first to successfully land on and return from the moon with samples. Of course, that race was won by the Americans in a very dramatic showdown on July 20th, 1969. That was a day when everybody learned the one lunar feature that people know today that they didn't know before that time is the Sea of Tranquility. And I'm always surprised by how few of the other named lunar features, of which there are over 1,000 on the Earth-facing side of the moon, have been are really identifiable by most people. You ask somebody what's the name of the feature on the moon, they'll say Sea of Tranquility, and then I learned the Sea of Crises that same day, July 20th, 1969, that the Soviet unmanned lunar return mission crashed there, thus ending their bid to be the first sample return. Same day as the Apollo 11 landing. It was very thrilling. Anyway, so it has been the object in the sky since forever. You can find references to it from long, long ago. Poets write about it, artists paint it. And of course, from the Observer's Handbook perspective, we're more interested in the science of the moon, but it actually extends well beyond that. It's a wonderful first target for any telescope, really. And it represents one of the great projects that can be done right from one's own backyard. It's the one item where light pollution is not really an issue, because on nights that the moon is up, it's creating its own light pollution, as it were. And but the good news is you can do it from your backyard. You can do it in the middle of the city. Heck, you can do it from your front yard if you want to. I got to the point where I used to leave the porch light on while I was observing, so I could read my handy dandy Hamlin Atlas of the Moon. Sorry for the backwards print. That was my guide for viewing all of the named features on the Earth-facing side of the moon, which is, as I say, over 1,000 features. That was a delightful project that took me something like 8 years to complete. Of course, the moon is essentially geologically dead. It's so dead, in fact, that its features have been named in Latin. So, the epitome of a dead language, I guess it's a joke. But it also, the names of the features reveals, as in many things scientifically, some of them were named before we fully understood what they were. And in astronomy, some of those early misunderstandings remain to this day. We still talk about umbra and penumbra on the sun when we're talking about sunspots as if they were shadows. They're not. And we talk about the Sea of Tranquility on the moon as if the moon has water, or for that matter, as if it had moods. It has neither. But those names have stuck since early days, and the corrections, we just work around what those words mean in the understanding of current knowledge. I highly, highly recommend us in the bottom of my lunar observing page, which occupies 4 pages in the center of the handbook. The Isabel Williamson Observing Program, which is done by the RESC Observing Committee, and that allows a potential lunar observer to dabble and learn the moon, or to go very deep and go for the Lunar 1000, which is a letter that goes to people that have observed at least 1,000 named features. The real challenge of the moon, its features don't change, with very, very rare exceptions. The features don't change. What is constantly changing is the lighting angle of the moon as it orbits the Earth, and that is a change in its orientation to the sun that allows us to see different areas of the moon in appropriate light as we go through the lunar month. You can't observe the whole moon in one night, no matter how dedicated you are. You want to see each area in good lighting, and for the most part, that is the times when the moon is. The area in question is near the Lunar Terminator on the lit side. So the Terminator being the day-night line, or basically the line that goes down the moon at any phase other than full, where we can see part of it's lit, part of it's unlit. Where the lit part closest to that strip is generally the area where we can see in the best three-dimensional depth perception, because of sunlight is coming in at a shallow angle, casting shadows, and those shadows really provide definition to what we're seeing. High features such as mountains or mountain ranges, crater rims, or even just lower level raises in the surface, things that are called wrinkle ridges are a good example, are best seen at those low lighting positions. And then anything that's deep, like a crater floor, is in darkness. So you can't necessarily see that crater floor right away, but you definitely get the sense of its depth. And as the sun rises on that region, as it will during the waxing, for our first half of the lunar month from new to full, you can revisit the same region, say on 2 or 3 nights in a row, and where the first night you'll see the floor of the crater is just a dark circle with no information in it. A couple of days later, as the sunlight gets a little bit higher, you can start to see into that crater floor, see if it has a central peak in it, see if there are rills in it. There are sometimes very good details that can be seen within a feature of a crater. So,
Bruce, do you mind if I show something to help demonstrate this?
Sure.
Okay, this is from Michael Watson. He's a RASC board member and and avid astrophotographer.
Yes.
And here's a photo of the waxing crescent moon where you can see this. I don't remember what this is called, but do you see that valley there?
Oh yes. Okay. Where are we? Hyginusville.
So I think
I don't see half of it, but yeah.
he might have it in the description. So you can see this big deep valley here. And then here's a photo taken from several nights later. The valley should be about here because we have the 2 Cs, but you just can't see it because the shadow has moved completely. So you go from so you can go from being able to see this big scar on the face of the moon to it looking like it's not even there.
Right. Yeah, and that's what changes. One of the when you look at the moon on consecutive nights, the lighting angles change by about 12 degrees from one night to the next. And so you're seeing, again, as the moon is waxing, you're seeing a new strip of 12 more degrees of sharp contrast detail, but you can also revisit what you looked at the night before and just enjoy the sort of more familiar scene that's fresh in your mind, but with the different light angle providing you different information. And there are some features that are actually best seen at high lighting. If you like to see the bright splash features from relatively recent craters, and by relatively recent, I might be talking about 100 million years ago instead of 3 billion years ago, such as the famous Tycho in the south center of the moon. Some of those types of features actually show up best when the moon is full, and it brings out the bright white spots and the white splash areas the best. But if you're looking for anything that involves depth perception, you really want to be looking when the feature in question is near the Lunar Terminator. So that became, for me, a labor of love that took a number of years to complete the list. And of course, completing the list doesn't mean I'm done looking at the moon for the rest of my life. It's obviously still a near and dear astronomical attraction. And part of the section, actually the first part of the section, is about what you can see and detect of the moon with the unaided eye. It's not all about looking at it through a telescope. Not everybody has a telescope, but everyone can enjoy the moon. And it does things on its monthly path over periods of from 1 month to the next as it goes through its phases, as it passes by bright planets and stars and has conjunctions with them, which are always temporary in nature, because the moon never hangs around in any one spot for long. It moves along at about its own, against the background sky, at about its own diameter every hour. So its diameter being about a half degree, which is basically the width of your pinky fingernail when you hold it out at arm's length. I think we talked about this last week. But the pinky is about a degree wide, but the fingernail is about a half degree, and it pretty much covers the moon, which is a nice trick to verify the full moon illusion, by the way. If you have what looks like a big fat moon on the horizon, just rising, stretch out your hand and hold up your pinky finger, and you'll see that your pinky fingernail just covers that fat moon. When that same moon looks much smaller and higher in the sky later that night, do the same trick, and you'll see the pinky covers it just about the same way. So that's just one little sort of naked eye thing that you can view with your eye, get the illusion, and yet find a scientific way to test it to prove that it is in fact an illusion and not a real thing, that the moon is actually bigger when it's on the horizon. It's not. So that's the moon does go through the cycles. James talked about a couple of them earlier. The Serous cycle of 18 years and a few days. The Metonic cycle, which is basically 19.00 years, meaning the exact same moon phase will happen on the same date at intervals of 19 years. So if you're wondering what the lunar phase was, if you're looking back in the past, well, 19 years ago today, it was the same as it is today. So that's a little short workaround. So Meton of Athens figured that out many centuries ago. I don't know how, but they're a clever fellows. That's only, a few times in a lifetime that you'll experience that cycle. A third cycle that's on the same range, and it is somewhat related to the Serous cycle, is called the regression of the node. And this is one where the lunar orbit is tilted to the ecliptic by about 5 degrees. So the moon, it doesn't orbit the equator of the Earth like other moons do around other planets. It generally is in the same plane of the solar system that we find the sun and planets, the ecliptic. But it does wander by about plus or minus 5 degrees. And over the course of just 18 years, the nodes, which are the 2 points on the lunar orbit where the moon crosses the sun's path, crosses the ecliptic, and eclipses can occur if the moon is full or new. Those wander do a complete cycle of the ecliptic in just 18.6 years. And that has a significant effect on how far north we can see the moon in the sky, or how far south we might see the moon in the sky at its extremes. It also has a direct effect on eclipses, what time of year they're going to occur. And it's really a fascinating cycle that can be monitored just with the naked eye by tracking the moon over, a longer period of time, and just sort of getting used to the parameters of its range. How high can it go in this part of the sky versus how low can it go? And it's coming up towards, in 2025 will be the next time that the nodes are optimally tilted, that the 5 degree tilt of the moon will be added to the natural tilt of the ecliptic that's caused by the tilt of the Earth. So we'll see at that time the moon as high as 29 degrees north or south of the celestial equation. And that's sort of the maximum you can experience. Whereas a few years ago in 2015, we had the other extreme, where even though the sun goes plus or minus 23.5 degrees, the moon would only go to about plus or minus 18. So that affects very much where it rises on the horizon, where it sets on the horizon. And those sorts of things were monitored by ancient archaeoastronomy sites such as the famous Stonehenge and many others that track not only the sunrise and sunset points, but also the extremes of where the moon might be seen to rise and set.
So Bruce, this little chart that we have here, the 2020 passages of the moon through 6 hour right ascension, is that like how high it is in the sky when you're talking about that?
Now, 6 hours is basically the very highest point of the ecliptic. When the sun hits 6 hours right ascension, that is the summer solstice. And that's when the sun is at plus 23.5 degrees north. So when the moon passes through that same area of the sky, that will be its highest declination for the month. Unlike the sun, where you can pretty much count on it always get to 23, as I just mentioned, that range could be all the way from plus 18 to plus 29. But those are the dates during the month, each month, that the moon can be expected to be seen highest in the sky. And as you look in the table, as you go through the year, the moon's phase is different each time because the moon's phase is dependent not just on where the moon is in the sky, but where the sun is. And of course, every month the sun moves about 1/12 of the way around the sky. So each month the full moon has also moved about 1/12 of the way around the sky. So when you measure the moon against the background stars, it reaches the same point in the sky, the sidereal month, about 2 days, two and a bit days earlier than the synodic month, which is the time from one new moon to the next new moon. If you look at the age of the moon, you'll see it's constantly getting shorter by a couple of days each month as it passes through that point. And the verbal description of the phase shows it going from a gibbous moon through a first quarter, through a crescent, through new moon on June 21st of this year. The moon is new on the day of the summer solstice, and it'll be high in the sky right where the sun is, but you won't be able to see it because it'll be basically exactly new. So this sequence is always the same. You see the waxing, it's the same to this extent. You always see the waxing moon high in the sky in the springtime, and you see the waning moon higher in the sky in the fall time and in morning sky. So for observing the moon in the evening hours, the spring is highly favorable. It extends also to viewing planets, and so it's that first quarter waxing crescent. You see those accessible phases, whereas in September and October, the moon is highest when it's basically around the time of last quarter, and rising, rises early, but not, relatively early, but in the overnight hours. So if you want to observe it at those phases, you'll want to be out in the morning before sunrise viewing.
Right, which not all of us are good at.
One other just thought I'll throw in there is that the moon in the evening sky, and the same goes for the planets. Often the very best time to observe it is before it's dark, fully dark, at which time it becomes a little bit glary, whereas twilight, especially I really like nautical twilight, when the sky is this nice deepening blue, but you don't get the glare. You just get a really nice contrast between the bright moon and the blue sky versus the bright white against black, which is a very severe contrast and less observer friendly.
Okay, so big tips are observe close to sunset or just after sunset, so there's less contrast. Or so there,
hour after sunset's kind of the sweet spot. Yeah.
Okay, an hour after sunset, observe it when it's not necessarily full, so you can look along that Terminator to keep an eye out for cool features, unless you want to see Tycho and the bigger features, in which case do observe it when it's full. And then this is a tip, I'm not sure, maybe you can confirm, Bruce, a tip I heard from one of our volunteers, which is if you're observing a rather full moon with binoculars, for example, wear sunglasses.
If you like to observe with glasses on normally, and sunglasses, sure. With a telescope, you'd really want to have a filter of some kind for high phase moons. I generally find if the moon is crescent or basically a quarter up to a quarter full, half full, I guess, depending on how you define your fractions. A filter is not really necessary, but as soon as it gets to the gibbous phase, where you can see more than 90 degrees of the moon, there's always a bright spot on the moon. That's what we call the subsolar point, where the sun's shining directly on it, and that sucker's bright. So that's the time where you want to be thinking about employing filters if you have them.
That's very cool. And we're gonna move on over to solar observing so we have enough time. But the one last thing I wanted to mention was that I've always liked the moon, but I've never realized how much you can observe with the moon in terms of how high up in the sky it is versus how low, how far away versus how close, and therefore the relative size of it. There's so much to observe with the moon. It's really a neat place to start with all of those, like keeping an eye on it day by day sort of thing, even if you don't have a telescope.
I'll add one more thing just to build on what else we talked about last week, which is the lunar librations. And that is, full moon is the time to observe what is called the libration zones, as the moon wobbles towards or away, so we can see it over the North Pole or under the South Pole, or wobbles east or west. At the time of the full moon, the Terminator essentially goes all the way around the moon. So it's actually the very outer extreme edges of the moon, which have the sort of gentlest lighting angles and start to reveal some detail, even though the shadows are mostly just going straight away from you as the observer. That is the time where if you look along the extreme edges of the moon in the direction where the handbook shows you that the libration is tilted towards you, that's when you'll see those features that are often out of sight. And that's a very subtle thing. It's more of an advanced observing thing. And you would need a number of years to go all the way around the libration zones and try and experience each area. But there's things to be seen of interest in all of the libration zones. Just, more lunar features. I mean, the Mare Orientale, which is a fabulous double-ringed lunar sea. Unfortunately, in one sense, it's on the edge of the moon that we can't really see it well from Earth, but when the libration is favorable, we can see it better. It's certainly worth taking the chance to view a full moon when it's tilted from the west and has better exposed that region as for instance.
Excellent, thank you. Cool. James, are you able to speak briefly to lunar occultations? Is that something you might be able to talk about for a sec?
Yes, I can. It's a pretty big subject, of course.
But before we jump into that, sorry, I realized I should say thank you so much, Bruce, for all of your information on the moon. That was incredible. There's a ton of information there. And we're going to wrap it up with these little bit of lunar occultations as much as we can.
Just briefly, the sun will pass, or pardon me, the moon will pass in front of a star or a planet. So that's an occultation. So when the moon passes in front of the sun during a total solar eclipse, it's not an eclipse at all. That's an occultation. Huh. The moon passes in front of a star. So these maps that we see in the section are all this. There's a lot of contributors to this. David Dunham is the lead contributor, and he has a team of people that submit the maps and a lot of the data that we see there. So if you were looking for an example, we're April the 15th. Let's go to the next map so it's something current.
Yeah,
next
true.
page. There we go. April the 16th of July. So you can see a series of tracks that start at the left edge and go to the right. They all do that because it's the Earth's rotation that drives that. So they start on the left edge and finish up on the right. And you can see the longitude that are given for each one. So you're, let's just pick there's Saskatchewan. There's one that goes across. It starts up at Edmonton, that's right, yeah. And it goes down. You can follow the track where it goes right through Washington, D.C. And so you could see there, if you're on that path, then there's a strong possibility that you're going to see that star wink out. And the star that's shown there is in the table.
Okay, let's go to the table. Do you know what
Yeah.
page on the table?
There they are,
Uh,
right there.
is it?
So
that would
we were looking at April. I think
Where'd it go?
what was the number there?
It says
905.
80 something.
80 S, yeah,
Oh wait, that's the
it's 90A.
90A.
So you
Okay.
go back to the table and find 90A.
Oh, is that in the proper
There it
occultations?
is, May the 25th. And you can see which star it is, star number 916.
And how do you find? Oh, okay. It's the reference number. See the bottom of page
U.S.
172.
Naval Observatory, and again, a lot of this data comes from the Astronomical Almanac.
Okay, so
And
then
then
that
there
was
are stars there that are known to be double, for an example. That's another. So there's a lot of information that was picked up through occultations. For an example, it's through an occultation that we discovered that the planet Uranus has rings.
really.
We saw a star moving through the rings and it winked in and out. So we thought, there's got to be something there causing the star to wink out and then come back on again. So that's how we discovered that Uranus has rings.
That's
There's a
cool.
lot of information that's gathered just but the shape of the object, you know, if it's an asteroid, for an example, that winks out a star and not the moon, because there are different types of occultations. There are lunar, where the moon passes in front of an object, or an asteroid passes in front of an object, or a planet. So we can determine the asteroid shape by several different people, some people north of the track, some people south of the track, and then we can determine what the shape of the object is. There's been a lot of information gathered that way. Long before telescopes were able to see these things, you could pick it up through an occultation. So yeah,
That's
there's
incredible.
people who are totally devoted to occultations, and that's all they do. You know, every
Wow.
branch of astronomy has people who are devoted, and this is one of them. And
It's incredible.
David Dunham is the occultation man. So.
So if you ever,
If I can butt in just for a second, the maps on grazing occultation, those lines are showing where the very edge of the moon, either the north or south extreme of the moon, will just graze the star. And anybody along that line has the potential of seeing the very edge of the moon cover and uncover the star, sometimes multiple times. The star passes behind mountains and valleys that are seen in profile along the edge of what's called the lunar limb. And repeated observations of these types of events have actually helped us understand the profile of the moon in its polar regions.
wow, that's really cool. Okay, so this is the starter kit for anybody who wants to get really into occultations.
Right, yeah.
That's really neat. Huh. Maybe it's worth taking a look at that and seeing if there are any that come by where you live, just to, you know, dabble in occultation, see if it's something that you like. Alrighty, I think we're gonna get on to talking about the sun a little bit. Kim Hay is here with us. Kim has written the entire section on solar observing. Patrick Kelly isn't with us today. Is anyone able to briefly talk about Ephemeris of the Sun, just super briefly? James, maybe?
Let's turn it over to Kim. She's
Okay.
been patiently all this time.
Okay, Kim, please take it away.
Oh, you're not on. You're
Kim, we
muted.
gotta unmute you. Here, there we go. Nope.
All right.
There, we can hear you now.
Okay, thanks for inviting me. The sun, unlike the moon, you do need to have a safety feature and a filter. Here's the filter. This is the filter that's used with a Bader film. This is used on my 80mm refractor that I use. And then we have the Thousand Oaks glass filter that I still use on my Schmidt Cass, not the cat.
I have seen your cat walking by, made me very happy.
So basically, if you're going to observe the sun, you have to do it safely, and you have to use a full aperture solar filter on the front of your telescope. if you get a telescope that has one of these tiny little things that fit in your eyepiece, throw it away. It is dangerous. The section that I wrote is basically just to touch upon the sun and how you can observe it and what you actually see. Right now we're in a deep cycle 24 coming into cycle 25, which has not really brought itself forward yet. However, once it does get kicking into place, we have these, the picture that's on the screen shows sunspots and sun groups and pores and penumbra and umbra. And basically this is how your spot may begin with this little, tiny little dot. And then if it's active enough, you'll end up with a large feature that can last for several days or weeks. It could actually rotate around the sun and come back again, which we've seen in the last cycle in 24. We've had, I believe it was one group that came by 3 times. So it's quite exciting when a sunspot actually shows up. There was one that showed up the other day. I did not get to see it. It was cloudy.
Oh man.
And it's probably gone by now because we've had cloud ever since. I was out Saturday observing the sun, and that was quite nice. And actually did some H alpha observing with and took some images. So I'm just learning on that. I'm just learning how to do that. So I don't want to get into that. There's different telescopes that you can use for your observing. A Herschel wedge is only something that should be used by an experienced observer because it will allow a lot of light in. When you use your filter, you're only getting like 1/100,000th of the light. So it's a very small amount of light that you're seeing of the sun. Never look at the sun without a filter. It will damage your eyesight. You can go blind because it is very bright. Counting sunspots and groups is something that you can do when you're looking at the sun, and you can actually have scientific data that you can send to the AVSO, and it's included in the relative sunspot number in the US. There's also Belgium that actually counts sunspots, so it keeps track of all the spots that have happened and groups that have happened over a rotation. Let's see what else there is. The sunspot or the sun cycle is about an 11-year cycle. And like I said, we're in a deep part of cycle 24, coming into our newest cycle of 25. And it's been very deep. I think the longest, this is the biggest cycle of deepness that I've seen. And I've been observing for close to 30 years. So
Wow.
this is an amazing cycle. The back page on page 188 has a lot of excellent resources for you to look at, and a lot of them are online, but you can actually see a lot of the pictures that are taken by SOHO and SDO of different wavelengths that the sun is being looked at. Of course, we have the solar or the Parker Solar Probe has been launched, and it's actually going and giving data of the sun and looking at its magnetic fields. And we've seen that as they come off, they're being bent into an S shape. And sometimes when the sun gives off a CME, it will hit the Earth and we'll end up with the aurora. We haven't seen too much here in the mid latitudes, but northern latitudes have actually seen aurora, and it was quite evident this spring. The purples and the greens and Steve, yeah, well, we haven't seen Steve, but
can you are these, yeah, this is aurora forms. For the uninitiated, can you explain what CME are?
Coronal mass ejection. So basically it is when material from inside of the sun will come up and it will explode off of the side of the sun, and it will push off into the solar wind.
And now I have a follow-up question. Is that what a sunspot is, or is a sunspot something else?
A sunspot is like a small magnetic storm. It's happening, it's churning. It may end up erupting into a large spot and then grow, or it may just collapse on itself and just be a pore and be gone.
Okay.
It's just, there's a lot of energy that's going on. The auroral forms that you see, a lot of this has been shown in Edmonton, actually has a lot of this lovely aurora. We down here in the lower part of Ontario are very jealous.
Yeah.
Several years ago, maybe about 10 years ago, we actually had a point where we had aurora and we had the butterfly effect. So it was right overhead at zenith, and it was pinks and whites, and it was giving you a butterfly effect, and it was beautiful. Again, that was because it was during an active season. Our sun was active. Right now, it's not very active, even though there has been some small auroral activity. So if you go online and you go to spaceweather.com and you see that the K index is up, go out, take a look. You never know, you might actually see an aurora. If you have a solar telescope, go out every day, try to observe around the same time every day. Take a look at the sun and see if you see a sunspot. You might actually see a small active region happening on the limb of the sun that the spot is coming around, and you might capture it before it's actually even numbered. So that's always exciting.
Yeah.
Good information, Kim. Is maybe some of our readers don't really realize that the sun rotates on its axis every 28 or so days.
Yeah.
Some parts of it are moving faster than others. Of course, the equator is moving faster than the poles, but about every 27 or 28 days, it makes a complete circle. So if you see a sunspot and it disappears around the edge, good chance that about 14 or 15 days later, it's still going to be there and you'll see it again. Depends how long-lived the sunspot is.
Exactly.
And there's a question from someone in the chat, Dave Ham, asking if sunspots always occur in pairs. Do they?
They start off and then they'll split. There's a leading spot and an ending spot, so that they'll always have a pair. Sometimes the back spot will fade off and then the front will just dissipate because it hasn't been that strong to keep it together. Sometimes you'll actually see a sunspot where it's one spot and you'll see it split. So that's a light bridge where you'll see that the spot will split. So it's kind of fun to actually watch the morphology of the sunspot.
That's cool. And then there was, if you're okay with another question, there's a question from Emma McPhee, which is, does the sun rotate clockwise or, oh no, it's been taken away.
I answered it.
Oh, James.
Counterclockwise.
It rotates counterclockwise when viewed from above. Okay, so that means that it's looking like it's going, like the left side is going towards the right side, yes? Okay.
Same as the Earth.
Same as the Earth in most things.
All the planets go around the sun in the same way. The only one that's different is Venus. It's upside down.
Silly Venus.
It rotates clockwise when viewed from above, but everything else is going counterclockwise.
And then there's a very mysterious question, which I don't understand because I'm not a solar observer, perhaps, and it's just K index?
Yeah, a K index is basically how strong the sun is and its magnetics. If you get a K index of a 4 and above, you may have a strong aurora.
Oh, I see. Okay, yes. Okay.
Basically, it's measuring the solar wind.
It's measuring how much stuff it's flinging our way, eh?
Yeah.
Okay. Cool.
Another interesting thing to learn is that a CME, a coronal mass ejection, once it occurs, it's going to take 2 to 2.5 days for it to reach the Earth, if it's aimed in our direction. It could be going off in any other direction, but sometimes it comes right toward us. And 2.5 days after a CME, we'll have a good chance of seeing an aurora.
And we can tell when a CME has happened visually, and then after we see the light coming towards us, it'll send the rest of the stuff in 2 days, is what you're saying?
It's like a solar flare and a CME are essentially the same thing.
Okay.
It's an explosion off the surface of the sun.
Okay.
Yep.
And then, since this is just a question that I know has come up a bit in relatively recent times, how much does the sun affect, how much does celestial weather, let's say, like solar wind, affect technology on Earth? And should we be concerned about that sort of stuff?
Oh, exactly. Yes, you need to be concerned about that. There's a whole study now that's being done on the solar wind and how it actually affects the Earth and how it affects the satellites that it can hit. Because if they're charged particles, it can hit a satellite and knock it out. So the space weather is a big topic right now.
That's really cool. And when you say knock it out, you don't mean knock it out of orbit. You mean like knock it out of usefulness.
Exactly.
Will fry the electronics.
Fry the electronics. Yeah, I guess
Most satellites are hardened. Electronics are hardened, so they aren't affected by the solar wind. But you know, if it's an extremely heavy or extremely bright outpouring of energy from the sun, it could still affect a satellite. And other things that get affected by it, power lines, railway tracks, all those kind of things. Anything that's long and metallic is going to be affected because it's electromagnetism.
Interesting. Okay, I always thought the stuff on the ground was sort like I always assumed it was to do with like the GPS and like the GPS satellites and that sort of stuff that are up there that would be taken out of commission. But I didn't realize that the stuff on the ground was in danger too. That interesting. That makes sense.
Yeah. You've got a lightning storm. That's a lot of that is involved with the sun. This is electromagnetism that we're getting from the sun. It's electromagnetism that causes lightning as well. It's an outpouring of energy. So, yeah.
I guess the cool thing about this is that the big 89 Aurora took down the Quebec power grid.
That's true. That was big.
Wow. This is really neat. I think it's really cool that you can, I know there's not much we can do in these scenarios. Like if celestial, space weather causes these big downfalls in our technology, other than be more prepared with our technology, there's not much we can do. But the cool thing is that you can actually observe the sun before this stuff happens, which is, it's one of those things I think a lot of people forget because the sun's so difficult to look at. But as long as you have a solar filter, then it does make it, and it's in the right spot. It's at the front of the telescope and not the back of the telescope.
Right. Yeah, definitely.
And it's also nice because for those of us who can't stay up late or don't like staying up late, you can do it in the daytime.
That's right. Exactly.
There's one last question. I'm not sure I understand it, so I'll ask, but I don't know if it's something that we can answer. Would an SME, I'm not sure if you mean a CME, like a coronal mass ejection affect an effect on Venus? Would it be observable on Earth?
I'm answering this right now.
Oh, okay. Thanks, James.
And the answer is they probably don't occur. A CME is a coronal mass ejection of solar material. You wouldn't get anything from Venus that would erupt off the surface and reach us.
And if I assume if the coronal mass ejection hit Venus, we wouldn't really be able to see it necessarily. Venus doesn't have aurora, does it?
Not that we're aware of.
Not that we're aware of.
Okay. Venus is tricky.
Doesn't have a magnetic field.
Oh, well, that would make things difficult. Yeah.
It'll get bombarded, but that's about it.
Yeah. Venus seems like a good place to avoid, no matter what. Oh, well. Well, are there any questions left from the audience members? We've been chatting away about the sun quite happily here, but it's now 4:30. So if anybody has any last minute questions, please fire them our way. Perfect. Okay, so thank you as well to James and Bruce, Bruce has just joined in the stealthy answering of questions without any of us noticing in the chat, so I appreciate that. It looks like we're all clear on the Q&A. Does anybody who's with us, so James, Kim, or Bruce, do you guys have anything else that you wanted to add about any of the sections that we talked about?
There's lots that we missed.
Yeah.
The page 189 is Solar Activity by Ken Tapping. He works at the Dominion Astrophysical Observatory in
Victoria?
Penticton.
Oh,
Yep.
Penticton. Yeah, he's the man about solar activity, and he's got a diagram on there that shows where we are in cycle 24. We're at the bottom, as Kim was saying, and this has been a long, long pause. And we don't know when cycle 25 is actually going to begin. It looks like it's going to sort of start, but we're not really sure. One of the ways that we can determine which solar cycle we're in is the polarity of the sunspot. So if a sunspot occurs up closer to the poles than at the equator, And that's one of the newer ones, probably from cycle 25 that we're seeing. But we know for sure by checking the polarity of the sunspot, when one edge is going to be a positive and one edge is going to be a negative. So if it's reversed, then we know it's a different cycle, generally. Sometimes we get anomalies even within a cycle, but generally that's what we would be looking for to see whether or not cycle 25 has begun. And it also gives us an indication of how strong a cycle it will be. But as you can see from that diagram, it hasn't been very strong for the last number of years.
Yeah. Got to get that sun doing some more stuff so we can have things to observe.
There's always something going on up there.
That's true. So I'm going to send, oh, what's that?
I was just going to say, if in the back where the references are in the website, if you go to spaceweatherwoman.com, she's actually a heliospheric physicist, and she talked about the sun a lot and talked about radio propagation, activity on the sun, space weather, also weather on Mars, and that sort of thing. So there's lots of information out there.
Okay.
She's a great follow on Twitter as well. And
Yeah.
we'll fill you in on real time on what's going on up there.
And that's really cool. I've sent out the link in the chat for anybody who's interested. And one last thing someone mentioned in the questions, that was, oh no, I've deleted the question already. Here is the link to all of the YouTube videos that we've already done from Observer's Handbooks, the Observer's Handbook series. This one will be added in as soon as we wrap up here today. It'll be added to that playlist and you'll be able to go back and rewatch these at any time you'd like. All of them are visible on this website as well, which you have to sign in with your membership information to access. And I think that pretty much wraps us up today. Thank you. Huge thank you to Kim, Bruce, and James for all joining us today and sharing their knowledge on all of this stuff. So sun and lunar observing is some pretty cool stuff, especially since we can always, well, we know that they're up there and pretty much anyone can see them anywhere you are. So it makes astronomy very accessible using these two targets. So thanks everybody. Next time we are going over, and I'm going to have to check for myself what we're doing. We're doing planets and satellites next time. So join us Monday next week at the same time, and we'll be talking about the planets instead.
Okay, great.
Thanks everybody.
Thank you.
Bye now.
Bye.
Bye-bye.